Hello students, welcome to Turito. In today's lecture, we are going to learn some more ideas of permutations and combinations. So specifically today we will be learning how to handle the circular permutations. Now there could be many different cases in circular permutations. So we are going to explore all different cases of circular permutations. Okay. So to understand circular permutations, what we need to understand is the symmetry and the overcounting. So whenever there is a symmetry, what do we used to do? Now recall our first lecture, we used to divide with the symmetry. Whenever there is overcounting, to balance the overcounting, we used to divide. So here that is exactly what you have to understand. You need to understand when to divide, when not to divide. Okay. So let's take up some basic ideas and try to generate a concept from the basic ideas. For example, let's say there are n different objects or n different people, it does not matter. You want to arrange them around a circle. Now how do we do that? So before we go for the n objects, let me just take 4 objects. Okay. So let's say there are only 4 objects or 4 people, it does not matter. Okay. So let's say there are 4 people and let's name them as A, B, C, D. We want to arrange them around a circle. So imagine that there are 4 seats which are placed around a circle and you want to arrange them around that in that round table in those 4 seats. Now if it is not a circle, how many total arrangements are possible? If it is not a circle, there are total 4 factorial arrangements. So for straight line, it is 4 factorial. Okay. So this is arrangements in a row, or we can also call it as linear permutations, straight line arrangements, everything. Now what is the difference when it comes to a circle? So for that, let me just explain you this basic idea. Let's say there is a circle here, okay, and there are 4 seats here. So one here, one here, one here, one here. So 4 seats are symmetrically placed around a circle and you want to arrange all 4 of them. So think of any one arrangement. Let's say I have taken this arrangement A, B, C, D. Okay, I have taken this arrangement. Now here, if you let's say shift all the seats, all the persons 1 unit right side, that means in clockwise, if we shift all of them like this, so when we do that shifting, what will be the arrangement that we will be getting? The arrangement is going to be D, A, B, C, right? Starting from this position, it becomes D, A, B, C. So I am basically taking this position as my reference position to explain you, okay? Now similarly, if I perform this shifting one more time, I am going to get C, D, A, B, right? If I perform it one more time, I am going to get B, C, D, A, right? So this arrangement, let's say I take this as A, B, C, D, then this arrangement will become D, A, B, C, right? And this arrangement will become C, D, A, B, and similarly this arrangement will become B, C, D, A. So here, taking that circular arrangement, if I keep rotating them by just one seat, so we can call them as one shift. So if I keep shifting them in clockwise direction, so I got actually 4 different arrangements here. Now in this 4 factorial, now recall the statement I have given in the first lecture. Whenever we permute any numbers, that n factorial is the maximum number of arrangements that you can get. Maximum arrangements cannot exceed n factorial. So these 4 factorial arrangements are the maximum arrangements. In these 4 factorial arrangements, this is ABCD is counted as one arrangement, this is counted as another arrangement, this is counted as another, this is counted as another. All these 4 different arrangements are counted as different when it comes to linear permutations. Now what is happening when it comes to circle? When it comes to circle, all these 4 arrangements are getting collapsed into one single arrangement, right? Because in circular arrangement, there is no beginning, there is no end. So here to explain I have taken this as the starting point, but there is no starting point around a circular table, right? There is no starting point. So there is no beginning, there is no end. So whether you take this arrangement or this or this or this, all 4 arrangements are treated as only one arrangement. So what is the symmetry here? 4 is the symmetry. So to get the answer, what do we have to do? We have to divide 4 factorial with the symmetry which is 4. This is going to give you the circular arrangement. Okay. So what is actually happening when it comes to circular arrangements? What is happening is there is a symmetry here. We have to quantify the symmetry and divide with the symmetry. Okay. Now what is this kind of method that we have applied here for calculating? It is the macro method. We have solved the entire system and divided with the symmetry. So holistically we solved it. So hence we call it as macro method. We can also solve this using micro method, which is we can go by case. So let us say there are 4 seats around a circle. Okay. So imagine that there are 4 seats and you are sending these 4 people and one by one, and you are asking them to select one seat and sit there. Okay. Now when first person goes, now all 4 seats are vacant. When first person goes, because first person will think that all 4 seats are actually equal, because there is no beginning, there is no end, seats are not numbered. So first person will feel that all 4 seats are actually same seats. So there is no choice for the first person. So first person selects a seat in how many ways? In only one way. So for the first person, selection of seat is only one way. Now first person has been seated. Now 3 are remaining and 3 seats are remaining. After first person sits in any one of the seats, for the remaining, now the order is defined, because he will be, second person will be comparing himself with respect to the first person. So if first person is seated, automatically order gets defined for the other seats and other persons. So for the remaining 3 people, we have to consider it as linear permutation and calculate it. So for the remaining 3 people, it is 3 factorial. Okay. So this way we can also solve this using micro. Now here when we go for the counting, our calculation is with respect to the people, and here we just calculate it with respect to the simple linear permutations ideas we have learned, and then we have just divided with the symmetry. So these are the 2 ideas that you have to remember. Okay. So now that I have explained for the 4 objects or 4 people, can we not generalize it for n people? Of course we can. Okay. So it is the same question, I have just duplicated the page. Okay. So now that there are n people here, in how many ways you can arrange them in a straight line? In n factorial ways you can arrange them in a straight line. But now there is a symmetry. So there are n shifts available, cyclic shifts, which are going to be symmetric. So symmetry is quantified with n. So we divide with n. This is our macro method. What about micro? When first person goes, first person has only one way of selecting a seat. So he will select a seat in one way, and he will be sitting in that place, and the remaining n minus 1 people, when they come, for them automatically now the order is defined. So for them it is going to be n minus 1 factorial. Okay. So this way we can understand the main logic of circular permutations with respect to these 2 ideas. Okay. So now if you have understood these, then you can generalize them and solve bigger questions also. Okay. But as I keep saying, do not learn the formulae by heart, learn the logic so that you will be able to solve questions. Okay. Come on, make a note of this. this page also. So here what you should be noting down are the explanations that I am giving, because the explanations are not there in any books. If you take any book in the market, no book gives good explanation than the teacher. So you better make your own notes based on the explanation. Okay. Now let's take a case of identical objects. Let's say there are n identical objects and you want to arrange them around a circle. Now if you go for the straight line arrangements, in how many ways you can arrange n identical objects in a straight line? In only one way, right? So when it comes to arranging objects in a row, if the objects are identical, it's only one way. Now because you are arranging on a circle, are you going to divide this with the symmetry? If you divide, then you are not going to get the integer number of ways, you are going to get fraction number of ways, which is going to be wrong. So whenever there is identical objects, do not blindly divide with the symmetry, do not do that. If you do it, you are going to get confused and you are going to get wrong answers. Okay. Now that is why we do not prefer macro method when it comes to circular permutations. Remember, when it comes to circular permutations, when there is a special case of identical objects, do not go for macro method, go for only micro method. Now how do we do it with micro method? When first person goes, he has only one choice. So first person can be arranged in only one way, and now there are n minus 1 remaining seats and n minus 1 people, but all people are identical, so they can be arranged in one way. So here the answer is going to be only 1. So now what have you learned from this problem? From this problem you have learned that if the objects are identical or people are identical, do not go for macro, go for only micro. Okay. Come on, make a note of this. Okay, so now let us take a special case of this. In how many ways n people could be arranged in r seats? Here number of seats is less around a circle. So how do we do that? So we can also go for the two ideas, macro or micro, because the objects are different or people are different. So we can go for the macro. Now n people can be arranged in r seats in how many ways? NPR ways. Now how many seats are there? R seats are there. So how do we quantify the symmetry here? Symmetry is R, so we divide with R here. This becomes the macro method. If we go for micro, all n people cannot be seated in R seats. So first we have to select R people. We select R people in NCR ways, and now we send the first person, you go and sit in one place. So he will be seated in one way because for him all seats are identical, and in the remaining places they can be seated in r minus 1 factorial ways. So this way also we can solve. This is micro, this is macro, and of course these two have to match. Okay. Now what happens if these objects are identical? So again the same idea. Now either it is circle or a straight line, it's always going to be one way. Okay. So the answer to this question is going to be one way only, because selecting r objects from n objects is one way, arranging them is also one way. So the answer is going to be 1 only. Now remember, whenever we talk about identical objects in circular arrangement, we only go for micro method. Okay. So now based on this we can generalize that for n objects taken r at a time, total number of circular permutations are NPR by r or NCR into r minus 1 factorial. Okay. And if the objects are identical, it's only one way. Okay. Now let's go ahead and take up some interesting examples. For example, let's say I have taken an example like this. Here there are 4 boys and 4 girls. They want to be arranged in around a circle so that boys and girls are alternative. So how do we do this? Suppose let's say if you understand this using the straight line idea, okay. So in straight line, how do they get arranged? There could be an arrangement like this, BG, 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 BG. There could be an arrangement like this, or there could be an arrangement like this, GB, 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 right? That means arrangement could start either with B or with G. Now boys, all 4 boys can be arranged among themselves in 4 factorial ways. This is the arrangement of boys, and girls can be arranged in 4 factorial ways. This is arrangement of girls. Now in the arrangement, it can start with a boy or it can start with a girl. So there are 2 possibilities here, so we multiply with 2. This is what we do in the straight line arrangement. Now let us do it for the circular arrangement. When it comes to circular arrangement, what are the possible cases here? So there are 8 seats around a circular table, and let us take these 4 seats and give them to boys, okay. So we can give them to boys, and now in the gaps we will be placing the girls, right. So there will be girl here, girl here, girl here, girl here, okay. Now in how many ways we can do that? So let us go by the same idea. We can arrange boys, that means when the boys are coming, all seats are vacant. So when boys come, boys take only those 4 seats, okay, this seat, this seat, this seat, this seat, boys take only these 4 seats. So boys can be arranged around this circular pattern in how many ways? In 1 into 3 factorial ways, right. So 1 into 3 factorial ways we can arrange the boys in these 4 seats. Now in the gaps we are going to arrange girls in how many ways? In 4 factorial ways. Now that the boys are already seated, remaining 4 seats are going to have some or other order. So that means for the girls it has to be normal permutation. Now that is it. There is no confusion of whether first seat is taken by boy or girl, it does not matter. Even if you place the girls first and then the boys, then also the number is going to be same, and we are not going to multiply this with 2 because there is no beginning and there is no end in circular permutation, but when it comes to straight line permutation, there is a beginning, there is an end, okay. Now let us try to connect these two. We have understood both ideas. Now let us try to connect the straight line with the circle. So here total number of seats are 8, so symmetry is going to be 8. If you divide this with 8, accidentally the number will become equal to this, but it is not always true. So that is why do not go for these kind of ideas, but go for these kind of ideas. Even though numbers match, do not rely on straight line permutations and dividing with the symmetry when it comes to circular permutation when special cases are involved, okay. So I keep discouraging you to go for this method, I keep encouraging you to go for this method only and try to learn it this way, okay. Come on, make a note of this. Okay. Now let us go to a different question. So here 12 people can be 12 people have to be arranged around a square shaped table, and imagine that there are 3 seats per side and all 3 seats are symmetrically placed. That is what we have to assume, okay. So that means there are 3 seats here, there are 3 seats here, there are 3 seats here and there are 3 seats here, okay. You want to arrange these 12 people around this square table. So in how many ways we can do that? Now look at this, if nothing is mentioned about identical or anything, we can do it using macro also, okay. So suppose let us say I am going by the macro. So straight line permutations are going to give me 12 factorial, but now there is symmetry, we have to quantify the symmetry. Now there are total 12 seats here. Now how many such cyclic shiftings are available? 12 cyclic shiftings are available, But out of these 12 cyclic shiftings, how many are leading to the symmetry? That is more important. Okay. For example, let us say you are sitting here. When you are sitting in this position, your left side is vacant, your right side is taken by a person, right. So, that means you can move your hand, left hand freely, let us say, let us assume that. Now, when you start shifting, you are going to get the same feeling only when you are in this seat. Only when you are in this seat, you are going to get the same feeling. If you are sitting in this, you are not going to get the same feeling of sitting in the left edge, right. So, out of these total 12 shiftings, these are the only locations which are going to give you the same feeling of sitting in the left side. So, here out of these 12 shiftings, only 4 are going to lead you to the symmetry. So, when we quantify the symmetry, symmetry is 4 here. So, we divide this with 4. Now, do not understand this as we are dividing with the number of sides. No, we are not dividing with number of sides. We are dividing with the symmetry. So, I am going to give you another example where number of sides is not equal to symmetry. So, please be little careful when it comes to quantifying the symmetry. So, this is our macro method. If we go for micro method, then what is the understanding here? When we go for micro, when first person goes in to sit. So, there are 4 sides here, all 4 sides look similar to him, because all 4 are having similar kind of setup for the chairs, okay. Excuse me. Okay, so all 4 sides are having similar kind of setup of chairs. So, when first person goes, all 4 sides will look identical to him. So, there is no choice of side there, but there is a choice of seats. If you look at all these seats, there are only 3 types of seats: left seat, right seat and middle seat. No matter which side you go, even if you go to this side, left, right and middle, if you go to this side, left, right and middle. So, every side is having only 3 types of seats. So, when first person goes, there is no choice of side, but there is a choice of seat and there are only 3 choice for the seats. So, he will select a seat in 3 ways and he will be sitting in that seat in one way. Okay. So, now first person is seated. Now, how many are remaining? 11 people are remaining. And now, when the first person sits, automatically order gets defined for the other persons. So, it becomes 11 factorial for the others. So, this way we can understand using macro and micro. Okay. Now, let us solve a different question. So, let us say we have a different question, but around a triangle. So, here in how many ways 15 people can be arranged around a triangle shaped table, and here also you have to assume that there are 5 seats per side and they are symmetrically placed. So, that means there are going to be 5 seats here, there are going to be 5 seats here and there are going to be 5 seats here, okay, and all seats are symmetrically placed. Now, you choose the method you want to do it by micro or macro. So, how many are here? Total 15 people. So, straight line arrangements are 15 factorial. We are going to divide this with symmetry. Whilst checking the symmetry, total 15 shiftings are possible, but out of them, to get the same feeling, there are only how many? 3 shiftings which are giving you symmetry. So, we are going to divide this with 3. If we are going by the micro method, when first person goes, he does not have any choice among the sides, but he has the choice among the seats, and seats are, one is extreme left, one is extreme right, second left, second right and the middle, right. So, for the first person, there are 5 choice of selecting a seat and in that he will be seated, and in the remaining n minus 1 seats, how many seats are there? Remaining 14 seats, 14 people will be seated in 14 factorial ways, because when the first person sits, automatically order gets defined. So, this way we can understand the simple idea of symmetry. Now the reason why I took triangle is to enhance your understanding of symmetry. Now I will confuse your symmetry, okay. So let me just take another example where number of sides is not equal to the symmetry, okay. So here total 21 people are there and there are 6 sides around a hexagon, and where there are 3 seats on one side and 4 seats on another side, and they are alternative. So that means, let us say if this has 3 seats, this is going to have 4 seats. If this has 3 seats, this is going to have 4 seats. This has 3 seats, this is going to have 4 seats. So how do we understand it here? So straight line permutations are 21 factorial. We want to divide with symmetry. Now total 21 shiftings are possible, but out of these 21 shiftings, there are only going to be 3 shiftings which will lead to symmetry. For example, here this seat will give you the same feeling when you are sitting here and also when you are sitting here, okay. So out of the total 21 shiftings, there are only 3 shiftings which will give you the same feeling or the same setup. So that means the symmetry is 3, so we divide with 3. Now let us go for micro for better understanding. When we send the first person will find 3 seat sides. There are 2 kind of sides, one is 3 seat, one is 4 seat. So there are 3 sides here, these 3 seat sides will look similar to him. So there is no choice among the side, but there is a choice among the seat. So he can go for left, right or middle, okay. And similarly, among these 4 seat sides, there are 4 choice. So if he goes for the side which is having 3 seats, he has 3 ways of selecting a seat. If he goes for the side which is having 4 seats, he will select a seat in 4 ways. So this is for counting both the cases. So in these many ways he can select a seat and he will be seated. Now the remaining people can be seated in how many ways? In 20 factorial ways, because when first person sits, automatically order gets defined. So this way we can understand it using macro and micro. But remember, whenever there are identical objects, you have to go for the micro only, okay. Come on, make a note of this. Okay. Next, let us say there is a different situation. Here you have to arrange 10 different beads around a necklace. Now mathematically necklace is a pure circle, okay. So but you might have seen a different kind of necklace. So generally there is a knot here and there is necklace like this and there is a design here, probably heart symbol or something. So generally necklaces have a different kind of designs. You may have a this kind of necklace also, you may have this kind of necklace also. So there are many types of necklaces, but mathematically a necklace is a circle, okay. So remember that necklace is a circle, it is a pure ring, okay, big ring. Now instead of necklace, questions also may come on garland, okay. So instead of this you can also get a question on garland. Now what happens when it comes to necklace and garland, which does not happen in the circle? So what is happening here? We can wear a necklace, right? We can wear a garland, but you cannot wear a seating arrangement. So here what is happening is, let us say I take 4 objects here or 4 beads, okay. So instead of 10, let us say I take 4 beads and I arrange them like this, okay. So every time when I am calculating, I am taking 4 as the example to explain you the concept. Now this is the arrangement. So now let us imagine that I am holding this necklace in front of me or garland in front of me. So the order is going to be like this: A here, B here, C here, D here. Okay, A here, B here, C here, D here. It's a circular arrangement. Now when I am holding it like this, B is in my left hand and D is in my right hand, right? So for me this ABCD arrangement is, counterclockwise, but for you this arrangement is clockwise, right? Because you are watching it from the opposite side. For you this is clockwise. So for me whatever is anti-clockwise is going to be clockwise for you. For me whatever is clockwise will be anti-clockwise for you, right? So that means if I just flip this necklace, I am going to get the other order. Okay, initially if it was clockwise, if I flip it, it will become anti-clockwise. And let's say if we are wearing it, we really don't know whether it was actually in clockwise direction or anti-clockwise direction, because we really cannot make it. Okay, so let's say you kept your necklace outside and you went outside, and I just changed, I just flipped it. Can you really make out whether it was left or right? You cannot really make out. So that means there is a symmetry here. What is the symmetry? Clockwise and anti-clockwise cannot be identified, which means if it was in clockwise direction or anti-clockwise direction, both are supposed to be same. So there is a symmetry. But when it comes to the total arrangements, when we generally calculate, let's say we take the 10 here, so 10 factorial by 10 is going to be our circular arrangements. So when it comes to this total arrangements, as I said, 10 factorial contains the maximum number of arrangements, and here this 10 is the cyclic symmetry. So when we shift them 10 units, so we will be getting cyclic symmetry. So we divided with the cyclic symmetry, but we did not divide with the clockwise anti-clockwise symmetry. Clockwise and anti-clockwise are still counted in this 2 times. So to balance that overcounting because of the symmetry, we are going to divide that with 2. Okay. So we are going to divide this with 2 to balance that clockwise anti-clockwise overcounting, because naturally in permutations clockwise anti-clockwise are already counted. Okay. So that means here this arrangement ABCD and also this arrangement ABCD, these two are treated as 2 different arrangements and they were already counted. So because these clockwise and anti-clockwise are same to us, we are dividing with 2. Okay. So here you can also perceive it this way: if clockwise and anti-clockwise are same to you, you can divide with 2. Or in question if it is mentioned that if clockwise and anti-clockwise are not important, then also you can divide with 2. Okay. That means if they are not important, that means even if it is in clockwise or anti-clockwise, both are treated as same only. Okay. So this is the idea that you have to remember when it comes to the arrangement around necklace or garland. Now let me explain you another point here. Okay. So before that, can you make a note of this? So here you have to be noting down why we are dividing with 2. Okay. Now let us go back to earlier cases. So when it comes to circular arrangement or arrangement around a polygon, and when it comes to seating arrangement or arrangement of the objects, we generally consider clockwise and anti-clockwise as different and perform the calculation. So in all these calculations, clockwise and anti-clockwise are already counted. But when it comes to garland and necklace, anti-clockwise and clockwise do not matter to us because we are wearing them. So here the default is not important. Okay, so the default is clockwise and anti-clockwise not important. But when it comes to simple cyclic arrangement, the default is clockwise and anti-clockwise are important. So here also the question may come that arrange n, okay, so for example this example, arrange n people around a circular table having r seats so that clockwise anti-clockwise are not important. If that condition is mentioned, here also you will be dividing. Okay, so here also you will be dividing if it is mentioned. If it is not mentioned, you will not divide that. And here when it comes to garland and necklace, if nothing is mentioned, you have to divide. Okay, so these are the default cases that students generally will be forgetting. So I have mentioned them once. Okay, now can we move on? Now let us move on to a different question. So here 3 identical objects and 3 different objects should be arranged around a circle. So there is a group here, one group with identical, one group with different. So whenever there are identical objects, we have to go for the micro method. So in this question we will not use macro. But before I do this question, let me give you one simple question. Okay, so I will give you one simple question here. So let us say there are 2 black balls, okay, and these are, let us say, identical, and there is one blue ball and there is one green ball. Okay, so I am going to give you easier example, and you want to arrange them around a circle. Okay, around a circular table. How do we arrange this? Now there is a combination, right? Some are identical, some are different. So what do? We go for the micro method. So what do we do here? We take the circle and around that we take 4 places, and first we go for the identical. First we arrange the identical ones, then we randomize the non-identical ones. So how do we do it? We go for the arrangement of identical balls. So these are black balls, okay. So let me name them as I. I stands for identical. So both can come together, this is one case, and both can come separate, this is another case. These are the only 2 cases available, right. Now you want to arrange them around a circle. So here we have arranged 2 identical balls here. Now if these 2 eyes are coming here, then also it is the same thing, okay. So for example, even if you are getting a different arrangement like this, it is going to be same because it is the cyclic shifting. So this is also going to be same only. So we are not going to take those cases. Okay, so just like you have studied in chemistry in benzene rings, okay. So ortho, para and whatever, okay. So it is just like that. So compared to the first location, what is the location of the next identical object, okay. So this is one way, this is one way. Now let us try to arrange the other 2, okay. So other 2 can be arranged because these 2 are different. So those 2 can be arranged here in 2 factorial ways, and those 2 can be arranged here in how many ways? 2 factorial ways. So the answer is going to be 4 only. Okay. Now let us say you go for the macro method. This is the micro method. If you go for the macro, what are your straight line arrangements? You generally do it with 4 factorial by how many identical are there? 2 factorial identical are there. Now this is a circular arrangement. You will be dividing with the cyclic symmetry, which is 4. Now check the number which is going to be 3 here. And what is the actual answer? It is 4. So macro is giving you wrong answers. So do not go for macro, okay. Now what if here clockwise and anti-clockwise are not important? So here in this case, clockwise and anti-clockwise, this and this are different, okay. So they are important. Now let us take another case where clockwise and anti-clockwise are not important. Then what happens here? So for first 2 identical objects, it is still the same number of cases. But when we are arranging blue and green, whether blue comes in the left or right, it does not matter because both are going to be same here. So for this there is only one way, for this also there is only one way. So it is going to give you 2, right. Now if you are going by this method, you will be further dividing that with 2 because of the clockwise anti-clockwise, that is going to give you 3 by 2. So you cannot have 1.5 ways of arranging, okay. So that way anyways this is going to give you wrong answer, macro is going to give you wrong answers, go for micro. So I have given you one simple glimpse of what happens when we take identical objects in circular arrangement. So there will be symmetry, but symmetry is not uniform. That is why dividing like this is going to fail, because symmetry is not uniform. This is the reason why macro methods fail for identical objects in some circular permutations, because symmetry is not uniform. Okay. Now you can understand the main idea here, and also you can make a note of this. Okay. Now let us take up those questions. Okay. So this is our first question. Now I have increased the number of objects. Okay. So there are 3 identical objects and 3 different objects. These are to be placed around a circle. So in how many ways we can do that? Let us take these identical objects as I and different objects as D1, D2, D3. Okay. Now because all 3 are identical, I is coming 3 times. Okay. So how do we do it? Of course we have to go for the micro method only. Now let me take a case where all 3 i's are together. Okay. So you can have one I here, one I here, one I here, and the other 3 locations are taken by the different ones. Okay. So this is one case. Now let me go for the other cases. Okay. So there can be 2 i's together, and there is one vacant spot here and there is one I here, and these 2 are vacant spots. So this case could be a different case. Now also I can be here and I can be here. There is one vacant spot here, there is another vacant spot here, I here, and vacant spot here. So this is also possible, right? But these 2, if you have a look at these 2, when clockwise and anti-clockwise are not important, these 2 are going to collapse into one single arrangement. Okay. But here there is nothing like that mentioned. This is arrangement around a circle, it is not a necklace or garland. So these 2 are actually same cases, they are different cases. Okay. Now next case could be all 3 in separate positions. For example, if one I comes here, there is vacant spot, there is I here, there is vacant spot, there is I here, there is vacant spot. So whenever you get these identical objects around a circular arrangement, you have to make cases. That is why if at all any question comes, that question is going to be very simple question with simple numbers like this. Now they will not give you any question of 20 identical objects, 20 different objects around a circle. Of course it is going to be very tougher for you. So if at all questions come, they come using these simple numbers only. Now we have shortlisted 4 cases. Now let us arrange those 3 different objects in these 3 different locations. In how many ways we can do that? For this case we can do it in how many ways? 3 factorial ways, right? We can do that in 3 factorial ways. And for this case we can do it in how many ways? Again 3 factorial ways, right? Because they are different, in these 3 locations they can be seated in 3 factorial ways. Once if these identical people are already placed, the remaining 3 people can be placed randomly, because once if these are seated, automatically order gets defined for the others, right? See, whenever I am explaining, I am also explaining by using the word objects, by using the word people, by using the word beads. So I am interchangeably using all of them, which is an indication that irrespective of whether you are arranging objects or people or beads or anything, it is the same. Okay. Now again for this case also we will be getting 3 factorial, right? What about this case? Here you will not be getting 3 factorial. Why? Because these 3 vacant spots are also having symmetry. Now these 3 I are anyways identical. So when these 3 places are to be filled, there is still a symmetry here. So the answer is going to be 1 into 2 factorial. Okay, so that is what you have to understand, that symmetry is not uniform. I hope you understood the main statement here. that the symmetry is not actually uniform. In some cases there is extra symmetry, in some cases there is not that extra symmetry. So that is why you have to go for the micro method. Okay. So now what is going to be the answer? Answer is going to be sum of all these. Okay. So what is the sum of all these? 3 factorial is 6, 6 into 3 is 18, 18 plus 2 is 20. So the answer to this question is going to be 20. Okay. So in 20 ways you can arrange all of them. So here clockwise and anti-clockwise are treated as different, right? What if they are treated as same? If they are not important to you, clockwise and anti-clockwise are not important to you, how do you perform the calculation? So if clockwise and anti-clockwise are not important, so that means this one and this one are going to get collapsed, right? So we will be deleting 1, we will be completely removing this, okay. Now only 3 are remaining. So when it comes to clockwise and anti-clockwise not important, so here there is only one arrangement, right? There is only one arrangement here, okay. So there is only one arrangement. How do we get one arrangement here? If you still have a confusion, so let me just explain it here. So you have, let's say, ABC, okay. So let me just explain it using ABC. ABC and CAB and BCA, this is one arrangement. In general, when we arrange any 3 in a straight line, we are going to get 6 arrangements, okay. And the next one is going to be CBA, right, and BAC and ACB. So if you check it here, ABC, BCA, CAB, these are the clockwise, this is the clockwise arrangement, okay. And the anti-clockwise are all these 3, these 3 are grouped as anti-clockwise, right. Now when it comes to circular arrangements, these 3 arrangements are just one arrangement only because they are having the same cyclicity. These 3 are also same arrangement. So 1 plus 1, which is 2 for circular arrangement, which is also same as 3 factorial by 3, okay. Now when clockwise and anti-clockwise are not important, you are going to get only one as the answer. So when it comes to 3 different objects, if clockwise and anti-clockwise are not important, around a circle you can arrange them in only one way, okay. So here we are going to get 1, okay. Sorry, not here. So here we are going to get only 1. Now what about here? Here when clockwise and anti-clockwise are not important, we are going to get 2 here, okay. What about here? Here, because there is a simple idea of 2 together and 1 separate, because there is a simple idea of 2 together and 1 separate, here it is going to be 3 factorial, okay. Now you have observed that symmetry is again not uniform, okay. So now what will be the answer? Okay, 3 factorial 6 plus 2 plus 1, it is going to be 9, okay. So when clockwise and anti-clockwise are not important, the answer is going to be 9 here, but now you understand that symmetry is not uniform. So whenever you have such cases, you make different cases and try to solve them, okay. So I hope you understood the main logic and main purpose of calculations here, okay. Come on, make a note of this. Okay. Now let me take you through a different example. It is the same example to discuss the second case that we discussed here. I think we discussed in the same page. So let us go to the next question. Here in this question, these are 3 identical beads and the other 3 are also identical white beads. Okay, so there are 3 black beads, there are 3 white beads. We want to arrange them around a circular necklace. So indirectly it has mentioned that clockwise, anti-clockwise are not important. Now, here there are two groups and both groups are identical. So, how do we do this? To do this, again we have to make cases. So, let me first arrange these black beads first. Okay. So, there is B here, B here, B here. Okay. So, and there could be vacant spots here. So, here 3 black beads are together, and we can take another case where 2 black beads are together and the other one is separate. Okay. So, you can take a case like this. Now, as we have discussed earlier, the symmetry of this is not going to occur because here circular necklace, so that means anti-clockwise and clockwise are not important. Now, what will be the other case? Other case is going to be the all 3 separate case only. Okay, these are the 3 cases. Now, we want to arrange the remaining beads. Okay. So, how many other remaining beads are there? There are 3 more identical beads. They can be placed in these 3 locations in how many ways? There is only one way because those are also identical. So, one way to this, and in this case also they can be arranged in one way only, and for this case also one way only. Now, what is the answer? It is 3. Okay. So, we can arrange 3 black beads and 3 white beads which are identical of the same kind can be arranged around a circular necklace in only 3 ways. Okay. So, this way you can understand the main logic of the identical objects being arranged around a circle. Now, here if it was not a necklace, if it was a simple circular table, you will be getting the other case which we omitted here, which is going to be B here, vacant here and B here, vacant here. This extra case will get added. So, for necklace it is only 3 ways, for circle it is only 4 ways. Now, see, for circle it is 4 ways, for necklace it is 3 ways. So, we are not dividing with 2 here. That is exactly the beauty of unsymmetric non-uniform symmetry. Okay. So, symmetry is there, but it is non-uniform. That is why we do not divide. Okay. So, this way we can understand the special aspects of identical objects. Okay. With this question, I am going to close the aspect of identical objects and I will take other applications. Okay. Come on, make a note of this. Okay. Now, let us take another question. So, here in how many ways all faces of a cube can be colored with 6 different colors? There are 6 different colors and you want to color a cube with these 6 different colors. In how many ways we can do that? A student has asked this doubt on YapMaster platform. I think his name is Sainad. Okay, Sainad Rao asked this question. So, I am solving it here. Now, what is exactly the idea here? There is a cube which is going to be symmetric from all locations, from all sides it is going to be symmetric. So, I have taken one cube here, this is a Rubik's cube. So, you can also visualize a cube here and you can understand how it is looking. Okay, so, here okay, so it is not exactly correct. So, let me just fix this. So, some arrangement is having an issue. So, I will just fix it quickly and then I will explain it to you. Okay. So, I will just fix it quickly, I will explain it to you. Okay. So, yeah, I think I fixed it. Okay. So, now here there is only one color here, okay, which is white, there is green here. Okay. So, and there is yellow here, there is red here, there is blue here. Okay. So, here if you just hold it like this and if you rotate, okay. So, there is a cyclic symmetry here. Also, if you hold it like this and if you rotate, there is a cyclic symmetry. And just as a cube, if you just look at this, then still there is a symmetry, right. So, all 6 faces are actually symmetric places. So, let us do the calculation with respect to the colors initially, okay. So, and then we will think about the others, okay. or we can also do it with respect to the faces, it does not matter. So when we choose, let's say, any one color here and let's say place it on any one of the sides, in how many ways we can select any one face here? We can select any one face in one way only, okay, because all are symmetric. So for coloring one side with the color that you have chosen, okay, so you are doing it with respect to the colors. So there is one first color here. Using that first color, you are trying to color the cube with one face, okay. So one face can be colored in one way because all are symmetric here. So when first color goes, all 6 faces are symmetric to the first color, so it does not have any choice, so there is only one way. So let's assume that we have painted it here, okay. So we have painted some white color here or something, okay. So let's say we have painted it here. Now how many faces are remaining? 5 faces are remaining. But there is of course symmetry. So how to handle the symmetry here? Okay, so for that, this is white color and opposite to that face. So let's say I am taking this white, this one, this face. Now opposite to this face, there is another face which is at the bottom. Top is white and the bottom is going to be some other. So this face can be colored now in how many ways? In 5 ways, because 5 colors are remaining, okay. So till now I have selected one face, any one face I randomly selected, I painted it, then I straight away went for its opposite location, because once if you fix one side, the opposite also is fixed, okay. So this will be remembered as the opposite to the first selection, so this gets an order. So when I select any one face, let's say I selected this face, then this face got the order, so that has 5 choice because there are 5 colors there. Now the top face and the bottom face are colored, okay. So the top is colored and bottom is also colored. Now how many are remaining? There are 4 faces which are remaining, which are the faces here, okay. So now if I hold them with the top and bottom and if I rotate, there is a symmetry here, right. And now there are 4 colors left and there is symmetry. So we can arrange those 4 colors in those 4 faces. We can paint them in how many ways? In r minus 1 factorial ways, right. So that means here it must be 4 minus 1 factorial, okay. So it's going to be 5 into 3 factorial, which is going to be 30, okay. So this way we can paint the Rubik's cube or any cube with 6 different colors, okay. But when it comes to Rubik's cube, remember that all colors are fixed. Always opposite to white there is only yellow, opposite to blue there is only green, opposite to orange there is only red. So when it comes to Rubik's cube, all colors are actually fixed, it is a standard cube. But for random cube we can always paint them using these many ways, okay. So I hope you have understood the entire discussion of today's lecture. When it comes to circular permutations, the idea is to understand the symmetry and divide with the symmetry. And also the idea is to understand that symmetry is not uniform. So that is why we have to go for the micro method. And when there are special cases, how to handle the special cases. We have taken one run through of these ideas. I hope you liked the discussion and enjoyed the ideas. So with this we will close the today's lecture. We will meet again in the next lecture with some more interesting ideas. Until then, have a great learning day. Learning shall never stop.